Did you know that there were once animals that were a blend of reptile and mammal? Let's discover what they are and why they're considered one of the most important species ever by seeing how these ancient beasts survived and even thrived in the harshest environments. This video is our first foray into the mutants known as therapsids. Therapsids are a group of synapsid reptiles that were the ancestors of mammals. They first appeared during the Permian period, around 275 million years ago, and were dominant terrestrial vertebrates before the rise of dinosaurs. They were the de facto rulers of any landmass. They're characterized by features such as differentiated teeth, incisors, canines, and molars, and a more advanced jaw structure, which are traits that later evolved further in mammals. This group includes various subgroups, including herbivorous and carnivorous species, and played a crucial role in the evolutionary transition from reptiles to mammals. The therapsid that we know the most about is Lystrosaurus. This genus of therapsid lived during the late Permian and early Triassic periods, around an astounding 250 million years ago. Lystrosaurus is particularly well known due to its abundance in the fossil record, especially during the Permian-Triassic transition. If you know anything about what happened during this time, that would be your first clue as to why this creature is so tough. Something monumental happened back then, which we'll talk about later. It's the pivotal reason why Lystrosaurus is such a hero to everyone that knows about them. Knowledge of this particular prehistoric beast is crucial to developing an understanding of the evolutionary transition from reptiles to mammals. Fortunately, because it was a hardy survivor, enduring harsh climates and events, it left widespread fossils that have provided significant insights into the paleo-environments of its time. Lystrosaurus was a robust, squat, herbivorous animal characterized by its distinctive appearance. It had a barrel-shaped body, short limbs, and a beak-like mouth. Its skull was relatively large compared to its body, with a pair of tusks protruding from the upper jaw. These tusks were likely used for digging and foraging, perhaps to root out tubers and other underground plant material. In terms of size, Lystrosaurus was relatively small by modern standards. Most species of Lystrosaurus range from about 1 to 1.5 meters, or 3.3 to 5 feet in length, with some species potentially reaching up to 2.5 meters, or 8.2 feet. They likely weighed between 80 to 200 kilograms, or 176 to 441 pounds, making them roughly comparable to modern-day pigs or sheep. Evidence suggests that Lystrosaurus may have been a burrower. Its strong forelimbs and tusks would have been ideal for digging, allowing it to escape harsh surface conditions such as extreme temperatures and wildfires by retreating underground. Lystrosaurus was a herbivore, feeding primarily on low-growing vegetation. Its diet likely included hardy, drought-resistant plants like ferns, which would have been more abundant in the devastated landscapes during rough times. Its ability to consume a wide range of plant materials may have given it a competitive edge in the resource-scarce environments of the early Triassic. Some researchers speculate that Lystrosaurus had physiological adaptations that allowed it to cope with the low oxygen levels and high carbon dioxide concentrations that characterized the post-extinction atmosphere. It could literally process and breathe air that would be poisonous to us humans, which is crazy to think about. Its barrel-shaped chest suggests it had large lungs, which would have been advantageous in such an environment. Lystrosaurus was likely a highly adaptable and resilient animal, as evidenced by its widespread distribution and survival through harsh environmental conditions. Its behavior would have been influenced by its environment, diet, and social structure. Fossil evidence suggests that Lystrosaurus may have lived in herds. This social behavior would have provided several advantages, including protection from predators and increased foraging efficiency. Herding animals can cover more ground and are more likely to find food and water sources in a challenging environment. Given the harsh conditions of the early Triassic, it's also possible that Lystrosaurus engaged in seasonal migrations to find food and water. Migratory behavior is common in modern herbivores living in arid or semi-arid environments, and Lystrosaurus may have exhibited similar patterns to exploit different regions as seasons changed. As many other animals died off, Lystrosaurus may have played the role of a keystone species in its ecosystem. Its grazing habits would have influenced the composition of plant communities, promoting the growth of certain types of vegetation over others. This, in turn, would have affected the distribution and abundance of other herbivores and predators in the environment. The success of Lystrosaurus likely had a cascading effect on the ecosystem. By maintaining plant communities and serving as prey for surviving carnivorous therapsids and other predators, Lystrosaurus helped stabilize ecosystems during a period of extreme environmental stress and upheaval. One tough nut had a profound effect on millions of species yet to live. We know Lystrosaurus fossils are some of the most widely distributed of any prehistoric vertebrate, but how widely distributed are they? Well, there are specimens found in Antarctica, India, China, Mongolia, South Africa, and Russia. This wide geographic distribution is a testament to the adaptability and resilience of Lystrosaurus, as it was able to thrive in a variety of climates and environments. In particular, the discovery of Lystrosaurus fossils in Antarctica is significant. During the Permian-Triassic period, Antarctica was not the frozen continent we know today, but was part of the supercontinent Gondwana, which had a much milder climate. The discovery and study of Lystrosaurus have had a profound impact on the field of paleontology. The genus has become a key indicator species for the Permian-Triassic boundary, helping scientists to identify and date strata from this critical period in Earth's history. Additionally, the widespread distribution of Lystrosaurus fossils has provided crucial evidence for the theory of continental drift. The presence of the same species on multiple continents supports the idea that these landmasses were once connected as part of a larger supercontinent. So what happened at the end of the Permian and the start of the Triassic to make Lystrosaurus so memorable? One of, if not the most, epic of Earth's catastrophic extinction events. The Permian-Triassic extinction, often called the Great Dying. This event resulted in the loss of approximately 90% of marine species and 70% of terrestrial vertebrate species. It is considered the most severe extinction event in Earth's history, marking the boundary between the Permian and Triassic periods around 252 million years ago. You know, anything that survived this had to be built tough. Thanks for investigating the life of one of history's most formidable survivors. It was tough, determined, brave, and worthy of respect. Be like Lystrosaurus, dig in when times are tough. Find a way to survive and thrive. Then you too might have a profound influence on all of those around you and those humans yet to come. If you love learning about dinosaurs and the ancient world, make sure to like, comment, and subscribe to Primalia for more exciting content. Share with a friend who loves ancient biology as much as we do. Stay curious.